Welcome to the second lesson of coordinate geometry. In this one we'll be focusing, much like the last lesson, on three skills that should be more revision rather than anything new. As it says on the screen at the moment, the three skills that we're going to be focusing on are being able to check if a point is on a line, so given a coordinate and an equation, and checking if that coordinate does fit the equation. The second one will be parallel versus perpendicular gradients in terms of our equations when we come to draw them, what that actually means. And finally, we'll be looking at a quick way to graph a linear equation. Remember that a linear equation is just a straight line graph. So let's jump into it. The first one, points on a line. There will be many times where you'll be asked to prove or discover if a given point or a coordinate is in a certain equation or lies on a certain line on a number plane. The only thing we need to remember is, as it says here in our green box, does the right hand side of our equation equal the left hand side? All we have to do to solve that is a simple substitution. So let's go ahead and have a look at a couple of examples here. Now we've got three different equations and the one point, and we have to test to see if our point of -2, 6 lies on any of these lines. Now remember, coordinates are always written as a pair of x and y values. So that actually means that on this number plane, along the x-axis we are at -2, and on the y-axis we are at 6, and where we are is where that point matches up with those two coordinates. So in terms of an equation, we simply sub those values in as x and y values. Here our y is our 6, and that equals -2 multiplied by our x value, which is also -2, and we add on 2. Now -2 times -2 gives us a +4, plus the 2 leaves us with 6, so we can give that one a bit of a tick and say, yes, the point -2, 6 does lie in the equation y equals -2x plus 2. The second example, y equals 4x minus 6, lining up the left and right hand side of the equation. All we have is a 6 on the left, because that's what y equals. On the right, we have a 4, and in brackets, the x value of -2 minus the 6. What that'll give us, 4 times -2 is -8, minus the 6 still, and finally that'll be -14. Now from that, -14 is not equal to 6, so that 6 can carry down on each line. Because this is not true, that coordinate is not on the y equals 4x minus 6 line. Lastly, let's check this third one. Y is on the left, so that is simply just a 6. 3 multiplied by our x value of -2 plus the 12. 3 times -2 is -6 plus 12. -6 plus 12 is 6. So we can give that one a bit of a tick because, yes, 6 does equal 6. And that's all there simply is to it. Here's a point on a line, sub in the point into the given equation, and check to see if your left-hand side equals the right-hand side. Okay, moving on. Next skill is parallel versus perpendicular. So we're talking about the gradient of a line, and we have two different scenarios. There are many more ways gradients can be related to each other, but more specifically you will be asked to deal with parallel and perpendicular. So here in diagram number 1, we have two gradients which are parallel. That is, you could continue those lines on forever and they will never ever cross each other. Opposite to that is our second graph on the right, and these two gradients are perpendicular. The distinguishing feature that makes them perpendicular is the right angle they create with each other. So here in red is our gradient M1, and here gradient 2 can be our blue line, and unfortunately when they cross big time and create a right angle. Now that has all sorts of properties to do with it, and let's have a look at those. So here our gradients M1 and M2, they're parallel, which means they are equal to each other. When two gradients are the same, they have the exact same slope and they're never going to cross. On the other hand, over here at number 2 with our perpendicular graphs, the relationship you can create with two graphs that are perpendicular to each other is when you multiply the gradients together, you will get -1. Or rearranging that equation, if you're trying to find a missing perpendicular gradient, it is simply -1 divided by the gradient given. Okay, first off, we'll have a look at whether a gradient is parallel, perpendicular, or neither. Our first example here. Our first gradient is 3/4, and our second gradient is 0.8. Now, First off, we can check automatically to see if they're perpendicular, which they're not, because to be perpendicular, when you multiply them together, you need to get a negative number, and we have two positives. So when you multiply two positive numbers together, you're not going to get a negative. So we're going to check to see if they're parallel. I'll do a quick conversion of 3/4 into a decimal, and 0.75 is not equal to 0.8, so they are neither perpendicular or parallel. And it's as simple as that. Okay, looking at B, we have a positive and a negative number, so that automatically rules out if they're parallel. And we're going to do a quick test to see if they're perpendicular. What I'm going to do is I'm going to multiply them together and see what number I get. Now, to help me multiply, I'm going to convert this first gradient, M1, into an improper fraction, which makes it 8/5, and M2 is -5/8, so I'm going to do a quick test and say I should get -1 when I multiply 8/5 by -5/8. Now on the bottom and on the top is a 5 and a 5, cancel out the 8 and the 8, so all I'm left with is -1. So that is a perpendicular graph, because when you multiply the two gradients together, you get -1. In our last example, we can rule out that they could be perpendicular because we need a positive and a negative to make that happen. What we need to do is test to see if they're parallel. It looks promising, but we'll do a quick conversion to find out. I'm going to say 0.45 is 45 over 100. Now you would do this on your calculator, but I'm just going to flesh this out into a mental fraction conversion from decimal to a fraction. 45 and 100 both have 5 in common, so I'm going to divide 45 by 5 and get 9, divide 100 by 5 and get 20, and that equals the second gradient. So that one is a parallel graph. And that's another skill done. The second part of this example, we're going to be using the second perpendicular identity, just so we don't have to scroll up or down. We'll put it on our screen now. It said a perpendicular gradient is equal to -1 divided by the gradient you want it to be perpendicular to. So there are our M1 and M2. Okay, a line passes through the points A and B with given coordinates as there. What is the gradient of the line parallel to AB? Now when you have a parallel gradient, those gradients are equal, so it's just asking what is the gradient of A to B. So answering part A straight up, we need to work out what M equals. Now remember, M is equal to the rise divided by the run. Or when you're given coordinates, the rise is the difference between the two y values, so y2 minus y1 divided by the run being the difference between the two x values, so x2 minus x1. Filling in the points we're given, y2 is here, which means y1 is that one, x1 is there, and x2 is the 4. So y2 take y1 is the same as 1 minus 5, and x2 being 4 minus a -2. So filling that all out, 1 minus 5 is -4, and 4 plus 2 gives you 6. So overall, simplifying that fraction, we have -2/3. So that can be our M1. So down here, gradient is equal to -2/3. Okay, the second part of the question said you need to calculate the gradient perpendicular to AB. So in this example, we can say that the gradient AB, which is equal to M1, is, we just worked it out, -2/3. We want one that's perpendicular to that. We want M2, where M2 is equal to -1 divided by our first gradient. Now this is going to get a little tricky, but I'm sure everyone will be fine. So we have -1 divided by -2/3. When you're dividing a fraction by a fraction, remember, keep the first one, turn it into multiplication, and flip the second fraction. Negative times a negative is a positive, and 1 times 3/2 simply leaves you with 3/2. So that is the gradient perpendicular to our AB line, is 3/2. And that's it. The last skill was a shortcut to drawing linear equations. Remember, linear equations are just simply straight lines. All we have to do is find out an x and y intercept. Now remember, an intercept is when the graph crosses the x or y axes, so it might be handy to label our axes here as y and x. Finding the x-intercept, so we need to find where the graph could be along this blue line here. Where is it going to cross the x-axis? Now, no matter where you are along that blue line, the value of y is always equal to 0. So we can use that fact and let y equal 0 in our equation, find out what x equals, and that is our x-intercept. The same thing for our y-axis. If you want to find where you are on this y-axis here in red, all you simply do is let x equal 0, because no matter where you are on that line, x is always equal to 0. You're not moving from side to side, you're simply going up and down. So we're going to use that fact. If you want to find the x-intercept, make y equal 0 and find out what x equals. When you want to find the y-intercept, let x equal 0 and find out what y equals then. You put those 2 points on your graph, draw a straight line between them, and there is your linear equation. Okay, first example, 3x plus 2. So to find the x-intercept, we need to let y equal 0, rearrange it to find out what x equals. So here is our step 1. Let y equal 0, so that means 0 equals 3x plus 2. Now, rearranging this equation, we have a plus 2 and we want to move it away, so we've got to take it away. So we have minus 2 equals 3x. Then we have a 3 attached to our x, and we need to move that away, and it's been multiplied, so the opposite will be divide by 3, which will give us, in the end, negative 2 divide 3 equals x. So there is our equation. We need to go to our graph. Remember, up here is the y-axis and horizontal is the x. Now, somewhere along this horizontal line, we need to put a dot at negative 2/3, which will be roughly about here. I'm happy with that. Okay, step 2 is we need to find the y-intercept, which means let x equal 0. So let's do the working out right here. X equals 0 means y equals 3 multiplied by nothing plus 2. 3 by nothing is 0, which leaves us with a simple 2. Go to our graph, put a dot at y equals 2, and draw a straight line between them. And there is our linear equation. And you could use a ruler to do that, and hopefully get a much straighter line than what I did, but that's all there is to it. One more example, and we'll finish up right there. Find the x-intercept means y equals 0. So step 1 here, we have our different equation. It's arranged a little differently, but all in all, it'll just make our calculations a little easier. So we will have 6x minus 2, which is multiplied by the 0, and that all equals 12. 6x remains 6x minus 2 times nothing, which is nothing, and that equals 12. If we want to get rid of the 6 attached to the x, we need to move it to the other side, do the opposite operation, which means we have x equals 12 divided by 6, which gives us 2. So we need to label our axes first, x and y. Our x-intercept is at 2, so there is our x-intercept. That's 1, that's 2, and 3. 1, 2, 3. Okay, step 2, we need to let x equal 0 to find where it crosses the y-axis. So down here, we're going to do step 2. We're going to have 6 multiplied by nothing minus 2 y's, and that all equals 12. Now, finishing this off, I'm going to have minus 2y equals 12. To undo this equation, I need to get rid of the negative 2. It's been multiplied by the y, so I'm going to divide it. And y equals 12, divide negative 2, which gives me negative 6. Now lining that up on my equation, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6 is down here. So there's my dot there. And I need to draw a straight line up through my graph, continue that down, and there is the linear equation. And all we had to do, rather than trying to fiddle around and find a table of values, is find 2 x and y intercept when x and y equals 0, plot those points and draw a straight line. That's it for today's lesson. Hope you enjoyed the video, and good luck.